Hello, and welcome to Module 8.2a, Division Properties of Exponents, the Quotient Rule. Our objective for today is that I can find quotients of monomials. Problem 1, dividing powers with the same base. Now, the quotient rule states that when dividing a power with the same base, the exponents are subtracted. So, in example A, it would look like this: 5 to the fifth minus second, and we get 5 to the third power, which we can simplify to 125. Now, let's do a little kind of alternate world here, and let's do expanded form on this. So we have 5 times 5 times 5 times 5 times 5 on the top, and we have 5 times 5 on the bottom. Why does it work that we can subtract? Well, 5 and 5 cancel out. 5 and 5 cancel out. So the number on the top, we subtract the amount of times we're multiplying it by it on the bottom in the denominator, and we're left with 5 to the third power. All right, so let's look at letter B. We have y to the 12th, y to the 9th. So we've got y to the 12 minus 9, which gives us y to the third power. Letter C. Ooh, we've got a fraction and we've got a whole number. So let's do this. So we have D, and it's the 7 halves minus, well, let's see, if we've got a coefficient of 3 and we need to find out how many halves that is, we multiply it by 2, and so that is going to be 6 halves. And so the result is D to the 1 half. All right, so now you guys are going to try that with letters D, E, and F on your own, and then check your work against mine. So letter D, again, we have one of these fractions where we need to get a like denominator. So we have y, and we have the 3/4 power minus 1 half. Well, how many fourths is 1 half? It's 2/4. All right, and so when you subtract that, you get y to the 1/4 power as your answer. Letter E, we've got 2 to the 6th power, 2 to the 4th power. So we have 2 to the 6 minus 4 power, which is 2 to the 2nd power, and 2 squared is 4. Letter F, we have y to the 8th power minus 2nd power, so we get y to the 6th power. Now, what do we do when things are more complex? If we have more than one variable or more than, maybe we have parentheses going on, we've got coefficients and variables, how do we work this? So the first step that we're going to do is we are going to simplify all of the coefficients first. Then we're going to work one variable at a time. We are going to identify which part of the fraction has more. We're going to place the variable there and subtract the exponents. And lastly, we're going to clean up the problem. We're going to remove any unnecessary ones, any unused fraction bars as appropriate. So let's look at this. M to the 2nd and M to the 5th. Well, first of all, step number 1, are there any coefficients here? There are none, so we go on to step number 2. Start with the variable M. Where do I have more M's? In the numerator or in the denominator? I have more M's in the denominator because I have 5 in the denominator and 2 in the numerator. So that's what we're going to do. We're going to put the M in the denominator, okay? And then we subtract our exponents. 5 minus 2 is 3, right? So now we go to our second variable, N to the 4th on top, N to the 3rd on the bottom. Where do I have more? I have more N's on top, and 4 minus 3 is 1. All right, so let's look at this kind of our alternate universe way, another way. And let's start with expanded form. So we have M, M, N, 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 right? So 2 M's, 4 N's over M, 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 N, N, N. And now let's go through and cancel out what can cancel, right? So we have 1M, 1M, those cancel. M divided by M cancels. Okay, that's all the M's we have. So what do I have left? Well, let's keep canceling. So N. So we have an N and an N. N, 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 N. Nothing is left to cancel. What am I left with? We've got one N in the numerator and three M's in the denominator. Right? So this is a way of seeing, visually with the expanded form, how we end up with what we end up with, right? There are more M's on the bottom, there are more N's on the top. And when everything cancels out, that's what we're left with, N over M to the third. And then just another point, you do not need to write the 1 there, okay? You don't need to write it. If it's N over M to the third, that is 100% correct. That is the most commonly written way that you are going to see something like this shown. If you were to write N to the first power, we would still accept that as being correct. All right, letter B. We've got 4x to the 10th, y to the 6th, over 8x, y to the 7th. Okay, cool. We've got coefficients that we need to simplify. So let's look at that part first. 4 over 8, what can that simplify to? That's going to simplify to 1 over 2. All right. So now I go variable by variable. X. Where do I have more x's? In the top or in the bottom? I have more on top, so the x stays up there. And how many more do I have? 10 minus 1, right? Because there's an x. We got 1 there. So 10 minus 1 would be 9. Where do I have more y's? Y to the 6th on top, y to the 7th on the bottom. There are more y's in the denominator. How many more are there? 7 minus 6 is just 1. So we have 1/2 or 1x to the 9th, or just x to the 9th, over 2y. So it could be written as x to the 9th over 2y. All right? Make sure you're doing your division and your simplification correctly with the fractions. Sometimes I see people have 4 over 8 and they write it as a 2 and they put the 2 in the numerator. Make sure you're paying attention to where the larger piece is and you're keeping those in their appropriate places. All right, letter C. We have x to the 4th, y to the negative 1st, z to the 8th, over x to the 4th, y to the negative 5th, z. All right, well, let's go through. Do we have any coefficients? Step 1, no. We're going to go one variable at a time now. We have our fraction bar. X to the 4th and x to the 4th. Do I have more on the top or the bottom? The answer is neither, and they just cancel out, right? X to the 4th divided by x to the 4th is 1. Where do I have more? Y to the negative 1st or y to the negative 5th? It's kind of a trick question. Negative 1 is the larger of those two numbers. So we're going to write this out. We've got negative 1 minus negative 5, right? Because we subtract the numerator from the denominator exponent, right? So 1 minus negative 5. And then z to the 8th over z. Where do we have more? We have more z's in the numerator, and there's 7 more. Okay, so now negative 1 minus negative 5 is going to give us y to the 4th, z to the 7th. We don't need the fraction bar anymore because everything is out of the denominator, so we don't need to worry about it. Okay, let's take a look at letter D. We have a to the negative 3rd, b to the 7th. We have a to the 5th, b to the 2nd. Where do I have more a's? I have more in my denominator. So a is going to stay in the denominator. And we subtract 5 minus negative 3. Where do I have more b's? In the numerator or the denominator? I have more in the numerator. And we subtract 7 minus 2. Right, so now 7 minus 2, so we have b to the 5th power. We have 5 more b's in the numerator, over 5 minus negative 3, we have 8 more a's. So it's going to be a to the 8th power. So b to the 5th over a to the 8th. Letter E. K to the 6th, j to the 2nd over kj to the 5th. So we start with our fraction. Where do I have more k's? I have more k's on top. 6 minus 1 is 5. So 6 minus 1. J, where do I have more j's? I have more j's on the bottom. So we have j to the 5 minus 2. All right, and when we simplify that, we've got k to the 5th power over j to the 3rd power. And letter F. We're going to start off with, we have coefficients, so let's do that. 22 over 2, that simplifies to 11 over 1, right? So we have 11 over 1. Y to the 2nd, y to the 3rd. Where do I have more y's? There are more y's in my denominator. And we're going to just show the subtraction, 3 minus 2. Where do I have more x's? In the numerator or the denominator? There's more x's in the denominator. So we do 4 minus 3. Where do I have more z's? Well, there's only a z in my numerator. So now we can simplify. We remove any extra pieces there. So we have 11z to the 4th in my numerator. The 1 we can just ignore because it's just a coefficient of 1. Y, 3 minus 2 is 1. And x, 4 minus 3 is 1. So you have 11z to the 4th over yx, or xy. All right, so we're going to go to the next page now, where there are 3 you-try problems that I would like you to do on your own, and then we're going to go over them as a group. So letter G, we have coefficients. So let's look at that piece first. 12 over 8, let's simplify that fraction. Those are both divisible by 4, so we get 3 over 2. Okay, that's our start. So now x to the 2nd, x to the 5th. Where do I have more x's? I have more x's in the denominator, so we have 5 minus 2. Y over y to the 3rd. Where do I have more y's? I have more y's in the denominator, so it's 3 minus 1. Let's simplify this. We have 3 over 2. 5 minus 2, x to the 3rd power. Y, 3 minus 1 is 2. Y to the 2nd power. So it's 3 over 2xy, x cubed y squared. Letter H. We have coefficients again, so let's look at those first. Step number 1, coefficients. So we have 2 over negative 4. Well, when we do that division, we end up with 1 over negative 2. So we have a 1, we have a negative 2. All right, m to the 2nd over m. Where do I have more m's? In the numerator, 2 minus 1, right? Because we remember there's a 1 there. And the next one, we have n to the 3rd, n to the 3rd. Where do I have more n's? It's the same in both, so they cancel out. And so what am I left with? I'm left with m to the 1st power, or just m, over negative 2. And when you write this, if you write it as negative m over 2, that would be acceptable as well. All right, letter I. Let's look at our coefficients. Negative 3 over negative 4. Well, that fraction can't reduce except for the negatives cancel out. So we have 3 over 4. All right. So now let's go variable by variable. Y and y to the 3rd. Where do I have more y's? I have more y's in my denominator. So we have y to the 3 minus 1. And x, there's only an x in the denominator, so it stays down below. So now I go ahead and I simplify. We have 3 over, we've got the 4 still. 3 minus 1 for the y exponent is 2x. So we have 3 over 4y squared x. All right. So example 2 is about the application of the division of monomials. So letter A, at sea level, there are about 10 to the 25th molecules in a cubic liter of air. In the stratosphere, about 30 kilometers above Earth's surface, the same cubic liter of air has only about 10 to the 23rd molecules in it. Approximately how many times as many molecules are in the cubic liter of air at sea level as there are in the stratosphere? So to find this, we're going to need to do sea level over stratosphere. All right, so sea level over stratosphere. So 10 to the 25th over 10 to the 23rd. Well, how many do we have there, right? We got 10 to the 25th over 10 to the 23rd. We subtract that exponent and we get 10 squared. 25 minus 23 is 2. And when we do 10 squared, we get 100. So there are about 100 times as many molecules of air at sea level as compared with the stratosphere. The stratosphere is much thinner, much less dense. All right, so population density. Population density describes the number of people per unit area. During 1 year, the population of Angola was 1.21 times 10 to the 7th people. The area of Angola is 4.81 times 10 to the 5th square miles. What is the population density of Angola that year? So we do population, so 1.21 times 10 to the 7th power over 4.81 times 10 to the 5th power. And let's do that division, 1.21, right? We're going to do our coefficients first. 1.21 over 4.81 is going to get us 0.252. 10 to the 7th over 10 to the 5th. Where do I have more tens? In the top. We have times 10. How many more do we have? We have 2 more. Are we in scientific notation yet? No, we're not. We need to move that decimal point over 1. So it's going to be 2.52 times 10 to the 1st power people per square mile. Okay, so 2.52 times 10 to the 1st people per square mile. Or roughly 25.2 people per square mile. All right, letter C. The human brain computes at a rate of about 10 to the 15th calculations per second. One computer specifications show that it can compute at a rate of 10 to the 8th calculations per second. How many times as fast is the human brain at making calculations as a computer? So we need to set it up, and we've got human over computer. So it's going to be 10 to the 5th over 10 to the 8th. Sorry, 10 to the 15th over 10 to the 8th. And where do I have more tens? I have more on the top. So it's going to be 10. 15 minus 8 is 7. So it's going to be 10 to the 7th times. And if we were to write that out, we have 10 million. So in comparison to that particular computer, the human brain is about 10 million times, can do 10 million times the calculations per second that computer can do. Pretty staggering. All right, there are 2 you try problems. I want you guys to do those on your own, and then we will go over them. So we have Canada's West Edmonton Mall claims to have the largest parking lot in the world with about 3 to the 9th parking spots. California's Glendale Galleria has about 3 to the 8th powered parking spaces. How many times more parking spaces does the West Edmonton Mall have? So we have 3 to the 9th over 3 to the 8th. Where do I have more 3's? I have more in the numerator. How many more is it 9 minus 8 is just going to be 3. So the West Edmonton Mall has 3 times as many parking spots as California's Glendale Galleria. Another population density one. So during 1 year, Honduras had a population of 7.33 times 10 to the 6th people. The area of Honduras is 4.33 times 10 to the 4th square miles. What is the population density of Honduras for that particular year? So we have 7.33 times 10 to the 6th people over 4.33 times 10 to the 4th square miles. When I do my division, 7.33 divided by 4.33, I get 1.69. And where do I have more tens? I have more in the numerator, so 10 to the 6th over 10 to the 4th is times 10 to the 2nd power, and that's people per square mile. All right. That is the end of our notes for today. If you have any questions, please bring them to class tomorrow. Otherwise, have a great day.